Hello everyone, myself Banu Prasad from Information Technology IT. My roll number is LE2. Today my topic is operating systems. My subject operating systems. Today my topic is component based APIs for versioning and distributed applications. Introduction. Operating systems application programming interfaces APIs are typically monolithic procedural interfaces that address a single machine requirements. The design limit evolutionary development and complicates application developments for distributed systems. In addition, typical OS APIs do not accurately address the needs of distributed applications. They have support for inter-machines communication but lack high-level support for accessing remote operating system resources. Are components the keys? Component software methods we have been primarily motivated by desire for reuse can eliminate this weakness. Software components are binary units of independent production, acquisition, and deployment that interact to form a functioning system. A component based OS API is constructed entirely of software components, each modeling an OS resource. To facilitate independence, components necessarily encapsulate state and functionality. The component modeling and OS resource will therefore contain all necessary access and manipulation functions. This encapsulation allows the OS resource to be initiated on a remote machine and also provides a natural unit for API versioning. Only the APIs must be component based. The underlying OS can be monolithic, monokernel, or component based. Our component based OS proxy COP, a prototype component based API, act as a traffic cop directing OS requirement to appreciate version or resource location. Component nuts and bolts. Interface is a contract that specifies how a component functionality is accessed. Interface takes the form of function or method calls, including parameters and return types. A component instance is a component that has been loaded into memory and is accessible by a client. All communication among component instances occurs through interfaces. Component software fundamentality maintains a strict separation between the interface and the implementation. Several methodological concepts facilitate reuse in component software. Independence. Independence allows components to be composed without introducing implicit interactions which may lead to subtle program errors. Polymorphism. Polymorphism allows components with differing implementations of the same interface to be interchanged transparently, allowing one component to substitute for another as long as it provides equal or great functionality that can than the original. COP runtime systems. At runtime, the application accesses the OS through the COP component layer. COP components implement the interfaces described above and like them can be roughly classified as factories, handles, or utilities. The OS returns a kernel handle to identify the resource. This handle, however, is only valid on the local machines. The enable remote access to the resource. The factory also creates an instance of the associated handle component and stores the kernel handle in the instance private state. The factory returns a pointer to instance of the handle component. The applications make subsequent access to the resource through the instance pointer. The instance pointer provides COPs with one of its main advantages over typical modern OS APIs. Instance pointers uniquely name the loaded resource throughout the system and act as the gateway to the underlying remoting mechanism. Versioning. COP's other main advantages over modern OS APIs is versioning capability. Follows directly from our factoring strategy and COM's robust versioning mechanism, including immutable interface and globally unique IDs. To make specific interface and application can store the appropriate IDs in the data segment. Alternatively, the OS binary format could be extended to support static binding to the dynamic interface. In the same way, the current OS supports static binding to DLLs or shared libraries with such as an extension and an application binary would declare a set of interface to which it should bind instead of a set of deals. Of course, COP aware applications can query dynamically for special interface obstacles to remote access of resources. OS callback functions are the significant obstacles to remote execution. Numerous APIs functions contains callback functions that the caller specifies and the OS invokes on certain events. This is a problem when the caller, that is, the location of the callback function, is on a different machine from the OS invoking the callback. COP solves this in the same way that it remotes OS resources. It wraps all callback functions with components. Instead of passing the addressing of the callback functions, COP passes a pointer to the components instance wrapping the callback, which the OS can then use to invoke the callback functions in a location transparent manner. COP fulfills the promise. The initial goal for COP is to support the development of the Microsoft Research Millennium system. Millennium will monitor the execution of a distributed component based applications and intelligently distribute the component instance to maximum performance. As components are distributed throughout the system, they still must be able to access remote OS resource. COP provides that capability. To this end, we have development remote access support for the registry, Windows, graphically device interface, and fill APIs. This subset consists of approximately 350 calls, enough to support the development of Millennium, including support for the legacy application provided by a legacy translation layer. Conclusion. Component software provides excellent support for the evolutionary development of software for the distributed computing. With an OS APIs based on components, a system that can gain considerable leverage in these areas. The OS can export different versions of the APIs, allowing the APIs to be modified without jeopardizing legacy applications. Instead, the support for legacy applications can be dynamically loaded. By modeling the OS resources as components in the APIs, a global namespace is created. An application can instigate and manipulate any number of resources scattered throughout a distributed layer. Natural access semantics for the remote resources is maintained by virtue of the encapsulation of functionality inherent in components. Application will no longer have to rely on add HOC method to access remote resources. Thank you.